Right there. All right, do we have speaker? Do we have speakers? No. Oh, I'd like to introduce Carrie Thompson from outboard, who's going to talk to us about diesel outboards.
Thank you, James. All, thank you for the invitation to speak to you about the upcoming new technology of diesel outboards. As James said, I'm with Mac Boring. On your invitation is Doug Natoshi. Doug is the president of the new group in Albany, Georgia of Oxe Marine. I'll get a little bit deeper into that through the presentation I'm going to do. Let's start. Let's hope we start. Bear with me. We have quite a few applications out there. I'll go over some of them during this presentation. So the big question initially is, why are we here? Well, Oxe Marine is part of a solution that we see out there. I've been in the marine diesel engine business for an awful long time. And what has happened in the past 15 years, maybe a little bit longer, is we're seeing more and more boats go from gas and or diesel inboard to diesel to outboard. Outboard engines have gotten bigger, more powerful, going on 45, 50, 60-foot boats. The opportunity to come in with a different solution of diesel outboard is coming. Oxe is part of the solution. Oxe has actually started in 2012 in Ängelholm, Sweden. In 2017, they got listed on a European NASDAQ known as First North. They can be seen and traded here in the US as well. In 2020, they got in bed with a electric diesel company in Europe, and they are looking seriously, hasn't done anything yet, at an electric dual prop using their belt drive system. They are compliant with EPA Tier 3, IMO 3, recreational Europe, and actually they have got an emissions, which is a little bit strange to me, with China. There's a emission regulation there. I had the new application that they have is a co-brand with BMW, and what they did there is they actually used a BMW engine in their bigger horsepower. I mentioned that Doug Natoshi is in Oxe, Albany, Georgia. He is the president of the newest group of Oxe in the USA now. But Oxe, as we go forward here, you'll see is really what they are is an engineering group. Again, out of Sweden, they're doing production in 2 different locations. They, of course, are a company with their corporate promises, values. The most important thing, as we all know these days, is customer attendance, attention, building to what the customer is required. So they're passionate to build this in a market where there's a need and support customers and, of course, us distributors. Advantages. I think maybe everybody who's been in the marine business has played around with gas and diesel knows the biggest advantages, but let me talk about them a little bit here. Gasoline in commercial applications a lot of times is not available. There is some issues with gasoline in four-stroke engines, marine engines, diesel engines, obviously, more efficient, less fuel burn, better range, life cycle, and life cycle costs. We're finding that compared, and what I'm going to do here, most of this talk is compared to gas outboard. Compared to gas outboard, less maintenance, more life. High torque. We can turn bigger propellers. Even though we're limited there, I will touch on that. And in some foreign countries, gasoline, in some areas, gasoline on the water is prohibitive. The idea, and Oxe's, what Oxe has done, they have patented the lower leg. And it was like anything else, any other idea drawn out on a napkin. So up in the cradle, they can put anybody's engine, anybody's diesel, electric, whatever it may be, and run it through their patented belt drive system. Here you're seeing the basics of it. It comes off the flywheel. There's a primary belt off the flywheel down to a hydraulic transmission, another propeller, another belt down to the propeller shaft. Comparison here of the gas outboard, which all engines are specifically made for gas outboard with vertical shafts running into vertical shafts down to their clutch at the bottom of the system, actually at the propeller shaft. The Oxe product, again, commercially used, and I will tell you, at this point, 90% of our sales throughout the world have been commercial applications. Hours. Always get the question, how long are they going to last? Well, we're still relatively new. We've got them running more than 3,000 hours, but applications that we're looking at, we can go with a high-speed diesel, plus minus 7,000 hours with these diesels. It's not been proven out yet. Engineering suggests as high as 10,000. We'll yet to see. Again, EPA regulations. The engine is mounted as it would be mounted in your car, with a horizontal crankshaft, again, off of the flywheel with a primary belt down to that transmission you're seeing in the little box. From that transmission straight down to a propeller shaft. So really below that transmission, there is nothing more than that belt and the propeller shaft for hardware. You do have passages up there for water and exhaust. And I'll show you that in just a little bit.
Question.
Yes.
On that shaft, not comparing to Volvo, but the torque of that shaft
Sorry. Go on.
will depend on the horsepower on that shaft that goes down.
You're talking about the propeller shaft.
Correct, going down, all the way down.
Right. Okay. So there's two models.
So you don't want to twist it.
There's two models.
Okay.
There is a 150 through 200 horsepower,
Okay.
different diesel than the 300 horsepower. So that shaft is a little bit heavier with a 300 horsepower. So to answer your question, no, it's engineered not to twist with the torque. Will it twist if you whack something?
I'm saying, you just said it, from one horsepower to the other, you have a certain size,
Yes.
and it's from one to the other.
Yes.
That's what I'm looking at.
Yeah. So it's
Everybody knows what Volvo did,
Right.
with the composite drives. They were okay with lower horsepower, but you get up into 6 to the 8s,
right.
it snapped
Right.
in half.
Yeah. I can tell you we're not seeing that. All right. But yes, the 300 is a heavier shaft than the 200.
Now, what if you
And-
do lower horsepower with a bigger prop? With more torque?
Again, engineered to take, well, I can talk a little bit, and I will talk a little bit about exactly what you're talking about, ratios. And really, it translates torque is torque of the engine, it's the ratio, and your propeller. So your question is, if we're a deep ratio, we put a big prop on there, is it going to harm the shaft? Well, we've engineered that shaft to go to the biggest, deepest torque we can get.
And the ratio between the engine and the trans?
The ratio is actually at the transmission. Well, back up. The ratio, that's not true. The ratio is at the primary belt, and I'll show you that in a little bit.
Okay.
All right, but to answer your question, it's engineered for the torque. I'll go one step further. That is they're using Yamaha shafts.
Okay.
So that's not their own manufacturer.
Okay.
yes.
Are you running a traditional gear loop in the lower unit?
I'm sorry, say it again.
Is there a traditional gear loop in the lower unit? or-
There is ATF
Okay.
throughout the belt system. The belts are wet.
Oh, okay.
The belts are cogged carbon fiber. The primary belt is roughly, well, the primary belt on the 150 to 200 horsepower is an 1.5 inch cogged belt. On the 300, they've eliminated the belt. It's a chain at the primary system down to the transmission. The output side of the transmission is still a belt on both applications, both horsepowers.
Thank you.
A little bit of music for you. I left this one in here, not necessarily. So here, they're showing the difference between outboard, the gear that that Oxe has versus what they do for gears for gas. It's a completely different setup. We're doing a hydraulic transmission with crash stop. Here it is again. You're seeing the vertical diesel engine. They're car engines, what they're using. On the what was, I'll keep in 125. We went from 125 to 200 horsepower. We're currently producing 150, 175 to 200. There's very little call for 125. Can still do it, but it's a 150, 175, and 200 horsepower, is using a 4-cylinder, 2-liter GM manufactured car engine, primarily used in Europe. So what you're seeing there is really the 150 to 200 horsepower. Coming off the flywheel is that primary belt. And again, a wet belt, only on the 150 through 200. The 300, that is now a chain. Output side of that belt goes into that hydraulic transmission. That's a disc type hydraulic transmission with crash stop. More robust than what comes from gasoline. And then the output side again of that transmission is a belt down to the prop shaft. Both models use a belt at that point. Let me bring up here, because they're talking about it. They touched on it here. It's a good point. On the gas outboard, most of your, I won't say it across the board, but a lot of times your access to filters, pump is either at the back of the engine or down at the bottom of the engine. On these engines, another point, these are freshwater cooled engines. So you have heat exchange here. It's in the heat exchanged engine. All access, that's your raw water pump, that's your oil filter, that's your fuel filter, dipstick, is all accessible at the transom or at the front of the engine. Again, raw water pump is sitting right on the crankshaft. You can access your impeller right there versus the gas outboard, which is down the bottom. One point I will make here is at this point in time, to change oil on this crankcase or ATF, the boat and or engine has to come out of the water because your access is down low to drain that. We're hoping sometime in the future that can be changed for the simple reason we're putting these in commercial use on 40, 50, 60-foot boats. Taking those out of the water is a bit of a headache. So right now it does have to come either off the boat for an oil change or the boat out of the water. Here again, a look at the transmission, which is above the water line. It is again, I said it's a twin disc type, not twin disc the manufacturer, but the friction plates are twin. It is ATF bath. And on the 300 model, the ATF is throughout the system. That's the lower or the primary chain on the 300. The transmission and the lower belt is all one reservoir well for the ATF. On the 150 through 200, there's two different wells. Also mentioned here, a reminder to me to tell you they have a quick shift ability. So I can be at low RPM, I can be in a slip clutch, trolling, slow mode, pushing your throttles up. It'll catch into a full lock-up position and go forward. So it has a slip mode in there for slow speed. Not always helphelpful. We can change that and get rid of that slip with a flash. We just have to tell it to get rid of that. Not all applications like that trolling mode. Fuel economy. Again, we're seeing every bit of, depending on how it's used, anywhere from 30 to 40% less fuel burn versus, again, gas outboard. Torque, higher torque. We're also seeing a lot more range. In some cases, at cruise speed, almost 50% further or better range on the diesel. So I'll interject at this point, 90% have been commercial applications, availability of fuel, life of engine, environmental concerns, and the torque. I mean, we're doing some push boats, pull boats with these things. Yes, sir.
Is it something that'll be available for a changeover? If we had a gas powered.
It can replace gas. It can we can repower. You got to be careful because they're heavier. So to give you an idea, again, 150 to 200 horsepower. Once we put fluids in there, that is approaching 850, under 875 pounds. 200 horsepower. Gas is 200. It's 500 pounds, 600 pounds, depending 4-stroke, 2-stroke. So we have to watch out on what boat it's going on. Same with the 300. The 300 with fluids in it approaches about 950, 975. I get a call from a guy who's got a 23-foot boat. He says he sees I have a 150 in it. I said no. Yeah. Now, we had our first demo boat had a 150 on the back of it, 850 pounds. It was a 21-foot boat. It was a rib, which has the buoyancy. So we don't have any trouble with the buoyancy on a rib. And I see a lot of these that are done in Europe. A good portion of them are ribs. Good portion of them are ribs that are being done. Search and rescue, you know, that type of thing. Just showing curves because we have curves. We have torque curves, fuel curves, and horsepower curves. Now, I snicker a little bit because I have looked for 6 years for a gas curve to compare it to. They don't produce them. But I will tell you, typically, better torque, better horsepower at cruise speed. So, for example, a gas 300 horsepower gas is going to get its horsepower at 6,000 RPM. At cruise comes off to 4,200 RPM. That horsepower on a gas engine at cruise drops off quickly. Whereas your diesel, you derived, in this case, horsepower at 4,200 RPM. You can cruise all day at this at 3,700 RPM, and your 300 horsepower has not dropped off that much. In this case of the 300, if I drop it back, for example, to 3,500 RPM, it's not far off of that 300 horsepower, maybe 275 at the lowest. So we always promote, when we're looking gas to diesel, cruise speed. In the case of a 6,000 RPM, it's turning that screw pretty fast, and faster than I can. I haven't brought ratio into it yet, but that screw is turning a lot faster. So a 300 horsepower gas at 6,000 RPM is going to go faster than what I can do at 4,200. But the cruise speed, fuel consumption, safety is what you get from a diesel over gas. We like to call it a modular design. I'll go back and say that Oxe's patent is the leg, the belt drive, the transmission, the way they set the engine in the cradle. It's always going to be a horizontal engine, electric motor that sits in there, and they'll take the power off that way. But they talk about modular design because their lower end, their lower is basically the same thing. Basically. Again, one thing I'll point out of interest is below, or I should say above, the bullet, the prop bullet, you'll see a spacer in there. We have the ability to have a 25-inch leg and a 33-inch leg, and that spacer will be in there for the 33-inch leg. One other thing on this slide I'll point out, why belt drive? Well, belt transmits torque a lot better. The result is a transmission that's more robust. If you whack something, well, you may take out that propeller shaft and prop. We've actually had the Coast Guard take out a lower leg, the lower portion you're seeing there, because they hit some flotsam or jetsam. But the point is that belt, you're not going to break in a gas outboard with a shaft. You're going to break a shaft. And a lot of times when I go into commercial fleets that are using outboards, that's all I see on the floor are lower legs, because that's what goes on them. Either they're I'll point out that lower piece there where the propeller is, the bullet is a drag through the water. So with the belt drive, they're able to keep that bullet smaller. If I was to run shafts and gears down there, they'd be a lot heavier. That bullet would be a lot larger. So we're able to keep that a lot smaller, less drag through the water. This slide is really geared towards military. The important market for us, or for Oxe, is the military. The conception of a diesel drive was really for military use, single source fuel, militaries throughout the world. So what this slide is showing is Oxe can package spares, workshops, deployment of something overseas for the military. On that point of military, it may surprise everybody listening here that the military doesn't move quickly. Our first application in the Navy came in 2016. They're still testing. They're still testing. Oxe gave them engines, and the Coast Guard as well. Prototypes, we took them off, and a couple of years later, they bought 2 pairs for boats. Both the Coast Guard and our Navy are running 1 boat with those 2 pairs. The other 2 pairs are sitting. Time. It'll come. It's just taken forever to get through the military. There are some separate groups. I do understand there's an overseas intervention group that has taken quite a few for actual use, but that hasn't been thoroughly reported yet. But what I am very familiar with is the Navy and Coast Guard, and they're both very slow.
Kerry, it's Mike here. Can I just interrupt briefly? I've got a question that's come through on chat from Gary. Gary asks, does Oxe certify independent mechanics to survey or repair these engines?
Okay, my slide that's coming up now will touch on that. We distributors are doing training, to answer your question. The certification really is, it's still early in development. There is training in Sweden, and there is Oxe does training in Sweden, and they do it in the US. Yes, you can be certified after that training, but that training at this point is for dealers. So what we are doing is setting up dealers throughout the world to service and maintain. I will say there are some occasions where a fleet will come in, as a fleet will do their own maintenance. If they're a large enough fleet and they have technicians, we will train them. Here it points out, again, the training in both locations, but it's a good point for me to bring something out. That 3rd bullet down says training and steering options. In this case, they say Glendenning. The steering for these outboards is what you would use for gas. In the US, it's C-Star. It is U-Flex is the other standard for outboard steering. You can use that. We have used Glendenning here in the US and overseas. There is a situation where, well, we did a 65, almost 70-foot passenger vessel. To get from the outboards up to the helm was roughly 125 feet. What Oxe supplies us for harnessing from the outboard to the helm is only, they'll do 15 meters, so they'll do roughly 50 feet. After that, they don't have anything. So we were able to work with Glendenning so we could use a CAN system. And we ran CAN all the way up to the helm. So that being said, we can run considerably further than what the harnesses that Oxe gives us. So in going forward, if you get on board boats, I think you may see a split of 25-75 of Oxe's harnessing versus a CAN system. The academy in Georgia or Sweden is full training, hands-on. You're going to go through it. In our case, we do pull apart the lower leg. Most of the guys that we are training are diesel guys. They're familiar with an engine. It's the lower leg that's all new to them. On that, both engines, as I said, meet emissions. They're common rail engines. They're turboed engines and freshwater cooled, I had mentioned. They're modern day engines. They're quiet. They're very responsive to the throttle. It's not what a lot of us might have grown up with, as you push your throttles or push your accelerator forward, and 60 seconds later, you've got acceleration. These accelerate very well. Production, I mentioned earlier, there are 2 locations. In Poland is the 300. They've joined with a partner in Poland by the name of Panlink. And at this point, we have not seen really any slowdown in production. The other location for the 150 through 200, that's the 4-cylinder, 2-liter GM engine that's being done here in US. The other questions or calls I get is, do you have any in stock? There's been a tremendous slowdown for 2 years now on supply of gas outboards. I have them in stock, but when I find out what boat it's going on, wait, and they find out that the cost of diesel over gas is about 2.5 times, they move on. It's not for every application. Now, by the way, those calls I get are mostly recreational. Sure.
You said the smaller one is the GM source engine. What's the 300?
Is a BMW. It's a BMW 6-cylinder, one that BMW actually started with that engine 2014. It's morphed twice now. And the most current, sorry, I know it's not at the top of my head, but it's their most current car engine, 6-cylinder, 3-liter.
It's probably the same engine they put in the 5 series.
Yes, yeah, it's their current 3-liter that they put in most of the bigger cars.
Are all the bolts on everything throughout metric
Yes,
on GM motors? Well,
yes. Always a surprise. Well, certainly less of a surprise over the years to us in the US that it's metric, but yeah. In fact, most of my drawings, which you'll see here, are coming in metric. Right. A lot of the spec sheets you're going to see in Newton meters, kilograms, millimeters. Yes. I'm in the business. I've been dealing with overseas diesel engines for a long time, so the conversions are here. Well, let me say they used to be here. Now I have to look them up. This is the plant in Georgia, the inventory. I think I briefed on before. Our inventory is good. We're not selling 1 million engines. So our inventory has generally been good. I will say in some cases of parts, spares, the suppliers have been a little bit slow, but other than that, we've got engines built and ready to go.
You all manufacture in Albany?
Yes, it's all assembly.
Assembly.
It's assembly, yes. So really here is the lineup. All the way to your left, you'll see the first ones that came out, which is really the 150. That was the first one we had gotten for prototype and then production. But soon after, following, came the 175 and 200 horsepower. Again, the GM block. In 2020, the BMW block, the change of the lower leg, chain drive came in, and then 2022, we got a white 300 horsepower. I go back and say that the majority of the sales have been commercial use. The recreational use, for example, the earlier ones, 150 and 200, was never popular. Popular commercial, recreational, no. But now that we've moved into 300 horsepower, we are getting more activity with a recreational engine. That's why it's white. And the most common, I will tell you right now, for recreational has been a tender, a super yacht tender. We've done half dozen at least, maybe more, either in a rib or in a hard body or in a fiberglass.
A quick question for you, going back to the belt drive real quick.
Yeah.
Because they're wet, I'm assuming that you don't get a belt line.
They're pretty quiet. They're pretty quiet. Heat, there's a heat sink in there, but that's primarily why it's wet. But no, they're quiet. Diesel is a different noise than gas. The gas these days are very quiet. And the other thing I always like to say about an outboard hanging on the transom of a boat, once you accelerate that, all your noise is behind you. At idle, they're quiet. They sound a little bit different. And you can, at acceleration, on some of them, you can hear some a turbo whine. But no, don't hear a belt noise. Don't hear a belt noise, no.
Yeah, it's probably not as loud as Verano.
All right, so those are the models we have currently. The 150 through 200, again, 2-liter inline 4-cylinder, low speed control, fuel economy, can-based helm control. We can run twin engines, two stations, low drag, I mentioned with a bullet. Yes, direct replaceable for a gas and or petrol outboard. Again, we've got to watch the weight and the boat. Quick shift capability, certification, IMO 3, European recreational, EPA. No clockwise, anti-clockwise. Let me talk about that a little bit right now. This engine, the 150 and 200, we can change the direction of the prop by flashing it. I have to come in with the diagnostic tool and make a few clicks to change that. On the 300, it's a little bit different, and I'll talk about that once I get to the 300. But the outboard that you get in a 150 and a 200 can be clockwise and counterclockwise. And down the bottom there, it says comes with 2 ratios. It comes with a 1.73 high speed or 2.17 high torque. So I can actually change, or you can, the owner can change the ratio. That primary belt, the one that comes off the flywheel, goes down to the transmission, can come off. 4 bolts are holding that on. You can pull that off, turn it 180 degrees, put it back on again, and you've changed your ratio. So high speed, 1.73, high torque, 2.17. I will tell you on this model, most of them are going out at the deeper ratio. We can turn a bigger prop, more blade area, more torque. Here on the 300, again, it's a 3-liter inline 6. It's a twin turbo, high and low. So you have the first turbo kicks in, low RPM. The second turbo kicks in, feeding more air to it, higher speed. You'll see a lot of that on diesel engines these days, and that's the way they can accelerate that piston a lot faster. So the BMW has a twin turbo configuration. We're cleaner. Ratio 1.34. On this one with the chain drive, there's only one ratio. Newton meters, peak torque Newton meters. It's 680, 500 foot-pounds. That's at peak torque at 1750. Bullet pull. We can give a lot more, considerably more bullet pull power than a gas. Fuel consumption, as I said, 30 to 40% less fuel. The newest thing, still in testing, and I'll go back to military. So they have a jet, belt drive in that shaft on the jet with an impeller. Here it is.
Gary,
here.
it's Mike again. Can I just butt in with another
Sure.
question?
Sure.
This one is from Malcolm, who says, have you got a dealer set up in Mexico yet?
I can't answer that question for you, but if Malcolm, Malcolm, at towards the end of this presentation, there is going to be a contact for you. Mexico is set up through North America, the North American group. So there'll be a contact at the end here that you can check. I'm sorry, I can't answer that for you, as my area of responsibility is East Coast, North America.
Okay, thank you.
Quick one on this. Let's see if she works. Doesn't work. Doesn't work. Let me go. That was just a quick video. This is a prototype on a prototype boat. I have not heard anything on this since spring, still under prototype in Australia. Yeah. Again, still in prototype, but the call for the jet has really been military. They want to be able to run that boat up on to the back of a landing craft, where they use an old jet to run it back up there. So we'll see how that forward again, slowly but surely with the military. It has, again, commercial applications, government, oil and gas, search and rescue, fishing, ecotourism, taxis, passenger vessels, and we meet all regulations. The important thing is we're diesel, passenger carrying vessel. Coast Guard disapproves greatly of gasoline. They will approve it. I've seen it, but it passes a lot easier if there's a diesel on the back of it. The other thing that I have noticed that comes up is water taxi or any scheduled vessel. If a outboard, gas or diesel, goes down, it's a much easier to replace that in a timely manner where they can stay on schedule. And we've already sold in that type of market where they can stay going versus an inboard, which if they're down on an inboard, it's going to take them a little bit more time to get up and running. Here, I want to point out drawings are available of everything, PDF, 2D, and 3D. Joystick, you can run joystick with ease. What you're seeing on your left-hand upper is the swing. The centers on the 300 is minimum is 32-inch, but we can go as wide as 36-inch. The other is a PDF of the drawing. That's kind of what you're going to see. But again, it's still available in 3D as well. Also, for parts. There are individual maintenance parts available, air filter, oil filter, and such, but there's also kits available. What you're seeing there is the 800-hour kit. Your maintenance on all of the diesel outboards, brand new 50-hour maintenance, we want to replace crankcase oil. So you'll get in that kit, you'll get an oil filter, you get a seal and a plug. If memory serves me, that plug is to replace the lower drain. A lot of times they're a pain in the neck to take out on any outboard. So they'll give you a plug and a seal. 200 hours is the next. So once you're finished your 50 hours and we're all moving forward, it's every 200 hours is maintenance. What you'll get on a 200-hour is fuel, oil, some O-rings. You will get anoids, salt water. They'll ask you to change the anoids at 200 hours. So you'll have, before you get to this 800 kit, you'll have 4, 200, 400, 600. Then you'll have an 800-hour kit. The 800-hour kit, as seen here, has got everything that's in a 200-hour kit, along with the belts. So you'll be doing a belt change. Engineering Oxe asks for that to happen at 800 horsepower. In this case, this is for the 150 and 200, because you'll change the upper belt. And the 300, that chain goes considerably longer. In fact, I haven't seen a maintenance on that yet, when they expect to do the chain. How difficult? You do need a tool, because you've got to pull your prop shaft. You've got to pull the shaft from your transmission, which is not that difficult to do. And then there's 6 bolts that lowers that down. But then to put your prop shaft back in, you need the alignment tool. Yeah, that's about right. About 3 hours. If you've done it a few times and you're set up, 3 hours. I like to talk about bollard pull, because that's what we're selling here. This picture here, quite a few years ago, on the West Coast, twin 200s. He does a lot of towing business, salvage business, but he was showing the pull, and there's a video up on YouTube of him pulling this tugboat. But more importantly, torque is useless if I can't get the right propeller on there. Outboard propellers, well, let me start a little bit different. We did some testing with a 300. They did it with a Mercury Inertia Eco, which we're using on our demo 300 right now. For forward speed and performance, it's a very good prop. This test they did with a a Michigan wheel, a bronze wheel, 2 different sizes. And you can see the thrust all the way over on the right-hand side, the difference. Now, why is that different? Well, real simple, is outboards exhaust through the hub. When they exhaust through the hub, that propeller's got a big hub on it, less blade area. So maneuvering is pretty tough. They don't back up well with this type of propeller, and you don't get the bollard, the push. So Michigan wheel, Europe developed this. We are exhausting through the cavitation plate. So that gives us the ability to put more blade on the propeller, smaller hub. And now I can turn maximum on both outboards. Maximum diameter is 17-inch, but I can get a whole bunch more blade area here. And it's been tested out, even with a passenger vessel that we did. They're backing up much better, and they have initial forward thrust to get that 60-foot, 65-foot boat moving forward with the Michigan wheel. So they did Oxe, Sweden, did this with Michigan wheel in Europe, and the outcome was much better thrust. Again, perfect for workboat. Not so good, 300 on a recreational because they want speed. So we'll go back to those designed propellers for forward speed. Yes, sir.
So that's a bronze prop. Is the housing and everything aluminum? They're
You're talking, yes. Yeah, it's aluminum. Again, I've got zincs down in there. I'm just, well, right above it.
And bronze all together.
Yeah.
Isn't that a zinc on the
Yeah.
out there?
Yeah, it's at the, no, that's not a zinc. That's actually a plastic cone. The zinc is below that cavitation plate. So, yes.
So
It's
that's a
the-
big concern.
yeah. Yes, at this point, until we see,
You got bronze.
oh, yeah. Yeah, throughout. As I said, every 200 hours, they give you a full set of anodes. But to your point, well, then again, don't forget almost all the props we're putting on here are either this bronze or stainless.
Being tripped up out of the water.
Yeah.
Not being used.
So you talk about changing the oil. Can the motor be tilted up and then changed in the water? We got pulling a 50-foot
The
commercial boat out of the water.
yes, I
Can't
can
tilt it up.
I can only we haven't done it tilted up, but if you're tilting up, you're still over the water. You know, the first thing out of my mouth is it's still over the water. And can you drop something in the water? Yes. What I do know is you can tilt it up and pull out the transmission fluid. That we have done. But the crankcase on this is remote. It's not a pan on the bottom of the engine. It's remote in the housing.
You couldn't suck it out.
Can't suck it out. So
How is it heat exchanger to access? And it doesn't have an air conditioner, correct?
yes, it does.
Okay.
Once you pull the cowling off, everything is there. You can get to the bundle. In fact, they have a kit to replace the bundle. Is that your question?
Correct.
Yes, it's readily accessible there.
So the prop, after lunch, we have this Sharrow
Yes,
prop. Have you tried those?
yes,
How are they performing?
better.
Better?
Better fuel consumption. In fact, if you go, he may show it. If you go onto oxemarine.com, they did testing roughly 3 or 4 months ago, maybe longer. That test is up there in the video with a Sharrow prop. They've got their claim of 15% better fuel consumption than a standard stainless steel outboard prop.
15%?
I think, if I remember, it was about 15% less fuel burned than the standard.
So if you get 15 off the prop and you get 50 off the diesel, so you 65% less fuel.
I will never, myself will never promote 50%. At cruise, I promote either side of 35%. So work from that, 50%.
That's significant. I mean, especially these commercial boats. Yeah.
Well, I don't know, that boat was a charter boat. I don't know how it's going to work if you need bollard. That would be a question for them. If you need that bollard pull or maneuverability. Again, I'll say to you, the gasoline outboards and the props with a hub are not designed and do not back up very well at all, period. Just a shot graphs again. But I can attest it's that the bronze prop gives better maneuverability. In fact, you can see, Jeremy, that this one was on they demoed with their Tideman. Applications, go back to it, a lot of government applications. That's really where the push is, single source fuel. Ribs, government rib again. Commercial and rec. Certainly Europe, bigger diesel fan than we are here in the US. They've sold considerably more than what we have here in recreational use. Here is another market that is popular, growing. I personally have been chasing aquaculture up and down the East Coast. This is a West Coast group that claimed over their gas. They claimed, I think they claimed almost 44% less fuel burn than what they were using. Rescue, search and rescue. This is US Gulf push boat. He claimed this is a repower, a job that burnt 44 gallons of gas, been able to keep it under 20 gallons. So there's your 50% there. But you know, if I'm pushing and I got more bolide, I'm not running the RPM that I would have to run with gasoline to get that, 50%. Ecotourism. Hurten Gruten has, excuse me, Europeans watching, I'm pretty sure that's how they pronounce. They have been using electric diesel outboard. They're very conscientious of their cruising. They're doing a lot of exploration type cruises. So they've been using diesel, a couple of different diesel manufacturers for outboards and electric as well.
They're using a grid there, so you have weight, all the weight of the batteries plus the diesel. Compensate for all that too.
Yes, don't know where the fuel is on that one. But again, I go back to the buoyancy of a rib.
That's what I'm saying.
Yeah, yeah. Again, I'll say oxemarine.com. They've got a lot of applications that they put up there, videos, all your brochures are up there, spec sheets are up there. Drawings generally would come through the likes of us distributors. So any drawings required, manuals required, we can get them off to you. This is me. I do commercial marine sales for Mac Boring for an awful lot of years. This has been something I've been working with now for about 6 years for distribution of Oxe. I have cards, or I'll leave some cards if anybody's interested. The Oxe USA, who is responsible for North and South America, Jeremy is your contact for Mexico. I'll leave that up for a little bit. Best way to get him would be his mobile phone. I can get you an email direct for Jeremy also. I am K Thompson at macboring.com. Anthony up in the top is a new senior vice president, but Tony is primarily involved with the military for Oxe. Doug was invited, couldn't make it, sent me in his place. demonstration, the obvious crash stop. You can actually do full speed and throw it in. My experience with anything over 2,500 RPM, throwing it into reverse, it just stalls the engine. But you're not going to hurt it. You're not going to hurt it. I'll indulge you with 9 or 10 minutes of me going over our cutaway. We have a 200 horsepower cutaway, and the next video I go through the belt drive and a few other of the points on the engine. That cutaway presently we use at shows. We have it up at a fishing tournament today in New Jersey, where we do have our demo 300. It's a 34-foot at Cape Horn. It's brand spanking new for us, our first demo with the 300s, but the cutaway's up there. But here I am. For those of you who don't know me, I'm Kerry Thompson, Oxe Marine sales for Mac Boring. Among other diesel engine lines that we handle, we're a warehouse distributor for Oxe outboards for Eastern Canada, East Coast US, down to South Carolina. We also cover the Great Lakes region. Oxe Marine is a Swedish company formed in 2012. They had intended to have their patented leg drive system set up for stern drive, but soon realized that the popularity of outboards would be much better way to go with this thing. The first production units in 2016 were the 125 and 200, which is the model we're looking at here. This cutaway is what we use for shows and is very informative, which you'll see in just a moment here. In 2021, or I should say early 2021, the second model, Oxe 300 horsepower, came out. This gave Oxe 125, 150, 175, 200, and 300 horsepowers. Today, the 125 is by special order only. The 150, 175, and 200 horsepower is in production here in the US, and the 300 in production in Poland. The diesel engine is a GM car engine manufactured in Europe, primarily used in the Opel cars. The engine sits in the cradle with a horizontal crankshaft like it would in a car. That was your heat exchanger there, the charge air. It comes off the horizontal crankshaft to a primary belt. The primary belt goes down to a hydraulic transmission. But let's talk about this primary belt a little bit more. It is oil-based or bath. It also can come off of here with 4 bolts. It can be pulled off, turned 180 degrees, and change the ratio. You have 2 ratios with this, a 1.7 and a 2.17. So it's called either high speed or high torque. From the primary belt, it goes into a hydraulic transmission. This hydraulic transmission is a lot more robust than the gas dog clutch that they use. This has crash stop, meaning you can throw this into reverse and you won't hurt this transmission. So for a lot of back and forth, forward and reverse, this transmission is a lot more robust. On the output side of the transmission is another carbon fiber belt. Both of these belts, by the way, are cogged belts. This also is ATF oil-based. So both belts and, of course, transmission is full of ATF. This 3-inch carbon fiber belt now goes down to the prop shaft. You can see the wrap here is a good 180-degree wrap. It is tensioned by being pinched in this portion of the leg. What is important down here that you can't see 100% is the size of this bullet. It's a narrow bullet, which is your drag running through the water. Less drag. The prop shaft can utilize a Honda, Suzuki, Mercury propeller. Solus propeller, also PowerTech propeller with a proper hub kit. At the transom, you'll find the raw water pump, seawater strainer, secondary fuel filter, oil filter, 130 amp alternator. There's a primary fuel filter water separator that is mounted remote, as well as an electric fuel pump. Here you'll see a variable geometry turbo, your air filter. It's a common railed engine. With this turbo, you find very good acceleration on this diesel engine. Here at the back of the motor, you'll see your charge air cooler, expansion tank, oil fill, and one of 2 lift rings. Here on the starboard side of the motor is your ECU, also your battery hookups. These are all push locks. Here is your connection for controls. You can see a little bit better over here, the 130 amp alternator. As with gas outboard, you have your trim and mounting to the transom. You can directly replace a gas outboard with this mounting configuration. All right, so now we've moved over to the Oxe 300. Here you're looking at our training engine. With the cowling off, we're looking at the BMW B57 motor. This motor was originally I believe it was N or M57 from BMW. In 2015, it was changed to this B series, B57. It's a 6-cylinder, inline 6-cylinder, 3-liter motor. Let's start with maintenance on it. Over here, again, like the GM engine and all Oxe engines, they are heat exchanged. So here you have your raw water pump. Over on this side, sea strainer, secondary fuel filter. So here we're on the port side of the engine, the raw water pump, 180 amp alternator. This is a transmission cooler and oil cooler. Up a little bit higher here, you see the oil filter. All right, on the starboard side of the motor here, you see the bi-turbo from BMW. They are variable geometry also. 1, 2 turbos, your charge air cooler, oil dip tube. Up a little higher, another shot of the air cleaner. All right, at the back of the outboard, you can see that the primary belt is removed off of here. We're doing work on the leg, but here's your coupling. Above is where the heat exchanger goes. It is removed at this point. You have your expansion tank. Notice on the top of the engine, it's common rail, but an air intake filter and a ventilation air filter. What is happening with ventilation is they are pulling air in to the cowling to help cool the engine. And the air intake filter, of course, is for internal air combustion. I'd like to talk about a couple of the basic things with both engines. Oil changes in ATF are every 200 hours, which is double what a gas outboard is. Maintenance kits are available, a 50-hour kit, a 200-hour kit, and an 800-hour kit. The 800-hour kit includes belts. Oxe Engineering would like to see the belts changed every 800 hours. Drawings in CAD and 3D are available. The control head has a low-speed control mode, also joystick compatible, and both engines are EPA Tier 3 certified. The dry weight of the 200 horsepower is 800 pounds. The 300 horsepower is 900 pounds. Alternator on the 300 is 180 amp. On the 200, it's 130 amp. Both come with 25-inch or 33-inch legs. Mac Boring's responsibility for distribution for Oxe Marine is the Great Lakes, Eastern Canada, Eastern US, from Maine to South Carolina. We're always looking for good dealers for Oxe Marine in those territories. If you're interested, please give me a call. And that wraps up my presentation and questions. Yes.
Couple of questions. If it's CAN bus or CAN control, does that mean it can be engine synced electronically?
Can it be synced? Yes.
Oh. With that, is there any input from the cloud in the way of engine management?
No, not at this point. You know, everything now is computer-based, laptop-based. You'll pull all your data information onto the laptop, and it can be emailed from there, but we don't have a connection to the cloud at this point. Not to say that it can't be done, though.
Because of automotive engines, can we use a code reader?
Yes. Yeah, and actually your displays will show you codes as well.
Your own displays?
They are the one that there's two available. There's 3.5-inch screen, which I do not sell. The 7-inch is a Murphy screen. It's that popular Murphy screen that a lot of people use.
What's the life expectancy hour-wise of those engines?
Again, I'll go back and say my experience of high-speed diesels. You tend to be plus minus 7,000 hours.
Okay.
Plus minus.
Yeah, I saw that they showed on the 300, you had a transport.
Yes.
You know, it's to my, what I've dealt with in the past. You don't know when the transport is going up, but when it goes up, it's too late.
That's correct.
So is there a typical, at 2,000 hours or 1,000 hours, replace the transport? No.
Don't have a maintenance on that, but I will say something that you just mentioned, that we have seen that belt get hot and destroy itself. What we would like to see, and there is not at this point, is a temperature sensor in there to tell us the temperature, but we haven't seen that. Now, I don't want to say that we've seen that a lot, but we have seen it. Low transmission fluid. The positive side, well, you can see a problem before you melt the belt. Negative side, you're putting another electronic sensor in. So I don't know what the future will hold for that. We've talked about it, but we haven't seen anything.
I know that, from my experience, after 4 years, just replace it.
Yeah.
Put a new one in.
And when you're in salt water,
Yep.
yeah, absolutely.
So, okay.
I get the GM engine and the BMW engine, whose transmission is?
Theirs. It's Oxe design transmission. Yes, sir.
Because Ox's thing is the transmission, is there any thought to using like a gas engine or something that's lighter and cheaper? Obviously the benefits of the diesel and for the commercial market, is obvious, but the cost, I would love to have a diesel outboard on my boat, but I can't spend 2.5 times the cost of a gas outboard.
Right.
So as you expand, is there any thought to trying to get in more to recreational?
I'll tell you right off, no, not in Ox's mind. At this point, there's no discussion of a gas. The discussion going forward in this world that we live in is electric.
Yeah.
But I will say this, you can put anything in that cradle, you know, if you want to engineer something, you put anything in that cradle.
But they're not gonna sell you a cradle.
You can buy, well, I know this defeats this defeats your cost issue. You can buy it, one of the diesels and take it out. On that note too, I'll mention that they have spare, we saw them in here. They will sell a loose diesel to go in there. But you know, if need be, it's possible. Like for like.
I mean, if you look at like, yes, the cost, I mean, I looked at 60 grand for 300 or whatnot.
70.
70, okay. So, I mean, yes, initial sting hurts,
Yes,
but you do 100 trips a year.
yes,
You know, and next thing you know, your fuel savings, it kind of catches up to that.
yes. Yeah, where is that? Well, we did it. If you do 1,000 hours a year between maintenance of 200 hours versus 100 hours, you know, you can see your return come inside of 2 years.
Inside of 2 years, if
Yeah.
you do 1,000.
Yeah.
Okay.
Yeah. A lot of variables on it, but yes, you can see the return on it. But the sale is, just quickly, the sale is to a diesel application. Somebody needs diesel, somebody needs a torque. Been doing this a long time. It's the same exact thing I ran against the Chevy V8, the Ford engine. And I'd be talking to those fellows that were putting hours or going offshore, doing range. And I'd say to them, I said, listen, I'll give you a better cruise speed. I'll give you more range and I'll give you safer fuel. All the positive things, gas over diesel. And, you know, yes. I still get the same thing. Yes. It makes all sense. How much? Well, the gas engine at that, the diesel engine at that time with a transmission, a small one, 250 horsepower, was $22,000. He'd say, what? I said, I'll buy a gas for $6,000. Well, doing the same thing again. Doing the same thing again.
Yeah. But if you look at long term,
Range,
it's definitely.
range, safety of fuel, and life.
Okay.
So you have to weigh that in, but it isn't for everybody. Yes, James?
Are things like the fuel filters, looks like or actually, but oil filters, hoses line, are not proprietary to Ox.
It's simpler to buy it through Ox, but I will tell you that on the 200, the fuel filters on the 200 are Raycor. The primary on the 300 is a Raycor, and memory serves me, the secondary on the BMW is also a Raycor. Oil filters, right now, for all intents and purposes, you'll buy through Ox. Certainly during warranty period. Yes, sir.
How about reliability?
Well,
That's always a huge concern.
right.
That gets really expensive or something.
We're still running these engines. We had a couple of hiccups in the early days that engineering took care of. Leaks, oil leaks, that engineering took care of. I'll answer the question this way. You shouldn't see any issues with it, providing your maintenance is correct. Your warranty is 2 years and we'll take care of any issues, but I'll throw a but in there. I'm running engines now for 6 years. You know, can you see? Yeah, the longest I knew of last year was Europe, and he was well over 3,000 hours. So if I was I just went through this with Ox Engineering. I have another passenger vessel asking me for a pair of 200s. And by the way, that 200 horsepower starts at 125, and with some hardware changes, we'll go to 200 horsepower. So you have a little bit different rating. What's your application, sir? How are you going to use it before I say, okay, you can put that horsepower in it? But going back, We looked at 35% loads on this passenger vessel, 2,000 hours a year, short runs. I threw it back to Oxe Engineering on that, and they said, you know, on that 200 horsepower, you're probably going to see 6,000 hours on it. So, you know, how it's used, will we see some hiccups? Yeah, we've seen some hiccups, but, you know, all in all, the concept of a diesel engine, reliability, the concept of a simple belt drive system, it's a more reliable way than the gas outboard. All right. Thank you. Thanks very much for your interest.
Kerry, and a big thank you from me from the UK. Thank you very much for your input. Fabulous, interesting presentation. And I'm going to hit the stop record button. I'm going to ask you if you can stop your screen share as well, please.